operations, right? Now we are saying we will try to evaluate a program based on how much memory it will consume. Okay, we are want to see like how much we want to now evaluate how the space requirement, right? Space requirement space requirement grows, right? Right? As, what should I say? As I think number of inputs, right? Number of operations increases or what? Let me find the right word. How much memory do we need to consume? Right. So we see what is the goal here is we need to find how much space would be required, right? How much space would be required? That is the objective. Let's see this. What do I mean by this? Let's go to this program first. And okay, let me also write some rule of thumbs, right? If you look at this program here, right? Let's take a simple one. It is not a simple one. Let me write a simple one. I think yesterday, right, we wrote this. So let's talk about this. Find some. If you look at this, right, if I want to find, let's say, what was the big O notation, the time complexity for this? It was n, I believe, right? It was n. So the big O notation for this method was n. So we have answer in one of the dimensions, which is time complexity. We're trying to find the space complexity. When you are looking at the space complexity, right, we should not be looking at the space required by the input. Okay, what do I mean by that? You can see, right, we are providing an input of n, I mean an input n, which is of type int. Now if I start going into the specific of things, int, right, int variable in Java takes, I believe, I think 32 bits, right? 32 bits, right? So n will take 32 bits of memory. Okay, okay, fine. Then you have one more variable here, which is a long. It will take 64 bits, right? Int I equals to 0. It will take 32 bits, right? And then you are just setting the value, right? Oh, sorry, you're doing the operation. So there is no space requirement for this, I believe, right? And you are increasing the value, so there is no space requirement for this also, I believe, right? And for this again, you have already set the space for it. It is just increasing it. Okay, I mean, it is just increasing the value. So the value of so there is no need for any memory space for this value also, right? You have already allocated this, right? So there was a need for this to be used. There was a need for this, and there was a need for this, right? I think these are the only three operations. So again, let's just generalize it. So how many space do you need? I think one, two, and three, right? When you are finding a space complexity, right, ignore the input part. So I will not consider the space required by the input. So let's remove it, right? So now what we are left with, we have to look only in our algorithm. We have to only look into our processing logic. How much space do I need if I want to run this logic? How much space? Let's consider as it as, we will not talk in terms of bits, right? I just gave you it as an example. Just try to understand. It needs one space, let's say, right? What is the space required for this? One space. Why one space? Okay, let's understand this part also. Why it requires only one space? Because you know, and we know, right, in the for loop, right, this statement only runs once. Correct? It runs only once, right? Because this is the initial, we have talked about it. A for loop works, you can divide the iterations of for loop into two parts. One is the first iteration, and second is the other, and second category would be other operations, other iterations. In the first iteration only, this block runs, right, which is the initialization value, right? And in the subsequent iterations, this is skipped, right? So this is done how many times? Only once, right? Only once. Okay, so how many spaces required for this program to run? One here, one space, and this is the second space, and that's it, right? So what is the space complexity for this? It is 1 plus 1 becomes 2, and again you will generalize it. So what will be the space complexity of this? 1. Okay, let me write it here. Let me grab it. Right, we need to find the space complexity, and what we're doing is we will ignore the input part. So ignore the input, right? Ignore the need of space for input, right? So we ignore this. We don't have to look at it. For this, right, how many space you require, right? One space. In this for loop, right, how much space is required? You can see I'm only initializing one value, and that was also, I'm creating a new variable which is I, and that two will run only once, right? So it will require one only, and there are no other space requirements, at least from this logic. So if you add them up, right, 1 plus 1 becomes 2, right? So you can say the space complexity for this is what? 1, and you will write space here after this. Okay, you will generalize this. I don't know if we have the answer to this for somewhere, but it would be O of 1, right? Let me modify it a bit. Okay, what I'll do is, what I will do here is, I will set the value as int I equals to 0 here. So I will set, uh, let's say I'll do something like this. I'll say int z equals to I, or 0, whatever you want to do, right? You are setting int z equals to 0 inside the for loop, right? Not nothing from the perspective, right? How many times you are creating a variable of z? If this for loop will run n times, how many times you would be initializing it, or you would be creating this space? Sagar?
For I, right?
For this for loop, right? No, for the not for the I. I have created a new variable int z equals to 0 inside the for loop. Okay. I am
Only
saying
one time.
not one time, right? Why one time? It is in the
I didn't
body
get
of
you.
the, see. Okay,
What is the question?
let me say this. You understood the other part, right? Which I was
Yes,
discussing
yes,
earlier, right?
yes,
So you understand the space complexity for this would be, and
yes.
1 plus 1, which becomes 2, and you will generalize it to say 1. That the space complexity for this is 1, right?
Yeah, got it. This,
Right?
yeah, this I
And
understood.
right, let me do one more thing here, right? What I'm saying is, if I do an operation like this, int z equals to, let's say, I, or 0, whatever you want, right? 0, let's say. If I do this, right, now give me the space complexity of this. Let me go back here.
N times. Every time we initialize it, right?
Absolutely correct, right? Right, Fizula? If I'm writing this, if I'm writing this, right, let's ignore this. So I'll ignore. For this, it would be 1. For this, it would be 1. But this space requirement, right, which I'm creating with every loop, with every iteration, right, depending on how many times I'll run it, I'll create that much space. So it will take n space, right? So if I have to write it, I will write it like n plus 2, right? And I can generalize it by saying n. So the space complexity for this program is what? N here. Fizula, we are good, right? Okay.
Yes, I guess.
Okay, great, right? So we are okay with this, right? So this is what a space complexity is, right? So again, the rule of thumb is you will generalize it, you will ignore the constants and the and just smaller values, right, as compared to a bigger value, right? If you have n square, you will ignore n. If you have n cube, you will ignore both n square plus n plus the constant. If you had n, you will ignore the constant values, right? If you have 5 or 6, right, you will write it as 1. Okay. So this is what the 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 rule of thumb for both the cases, the time complexity and the space complexity, right? And what are we looking at when we talk at about time complexity? When we talk about time complexity, we look at from the execution time, right? How much of the execution time will increase, right, if the number of operations increase. Okay. execution time increase as an increase, right? As an increase, and we notify it by saying like this, right? O of fn, right? But let's say we found that the value is O of n, so we say O of n time. We write it like this. If we talk about space complexity, we are looking at how much memory space is required for it, right? And how memory space, right? How the memory space is increasing as n increase, right? What will happen here is you will write it again in the similar way. The notation is same, O of n, and you will say, let's say O of n, whatever the value is, you will write it here, and you will say space. Okay, and we understand like how it is working, right? So you have in the space complexity, you have to look right how many times the space is getting created. That's it. Okay, and the way the things are working, the other rules of thumbs are same. Right, let's go and solve these questions again. So we will go back to our questions. We already have them. Uh, the foundations, right? Let's try to find the space complexity for them. So what is here? We'll ignore these two parts, right? If you look at this, it is taking one space, other space is taking, this is also taking one space, right? So 1 plus 1, 2 space. Okay, fine. If you look at int I equals to 0, right? How much space this is taking? Only one. I less than n, it is just doing the operations which you are not interested with. This is also okay. And for a, we have already set the value. So there is no space, no additional space requirement, right? We already have a space for this. So we have taken 3 space till now, right? If you go ahead, this is the 4th space. But again, for B, we have already have the value. So we are not creating a new space every time. So how many space? 4 space. 1, 2, 3, 4. So what should be the space complexity for this? I think 1. Right? Let's go back and check. If we go back here, you can see, right? O of 1. Right? Let's go to the second question, which is this. See here. Again, we'll ignore this part. We'll look at this. Int a equals to 0, 1 space, right? It requires 1 space. If you look at the for loop, right? How much space it is required? 1 space only, right? It requires 1 space. Okay, now tell me, this is interesting. Now tell me what is the space required for this? Fizula or Sudhakar? If you know the answer. How much space?
We are initialized here, right? Every time n changes, right? N value will be the one.
Try to understand like how many times this line of code will be running.
That
It will
will
run.
be
It will be
10 times.
running.
10
It
times.
will be running. Yeah. Yeah, Fizula.
n square.
Okay. It would not be n square. It would be n time, I believe.
10 times.
N times, because for every time the loop is running, right, a new space will be created. And this loop is running how many times? N times, right? So what will happen is for every run, you need a new space, right? Because every time a new variable of j would be initialized, right? Right? So what will be what's happening is, let me just grab it. Let's try to understand this. If you go back, we- this part, and over here, let's write the space complexity. The space complexity will be this. Uh, for this, we'll ignore. Let's ignore. For this, it is 1. For this, it is again 1, right? But this thing, right, will run how many times? Every time this for loop work runs, right, this will be again initialized. If this for loop runs n times or 1 time, it will be 1, right? If it runs n times, it would be creating a space for j n number of times. So the space requirement for this thing is what? N here, right? And it is because the way it is written here, right? If it was, I mean, since it's a nested loop, right? Every time it would be done like this only. So what is the space? What is the space requirement for this? 1 plus 1 plus n. So it becomes n plus 2. And I can generalize it to say it would be n here, right? The space complexity of this program is n. I hope it is n. Oh, it did not. What it did not provided the space complexity. Okay, it is only time, but we understand this, right? What is the value of this? N here, right? We are okay on this. Right, Fizula?
One doubt. Is it n or is it? I'm just confused with space complexity because we say like when it is an array and all, then it becomes n. Else it becomes a constant, right? Like, I guess
Let me come back. So
because you know that I mean one problem we did earlier also like that z1, right? Now when I'm thinking, I think it's 0 of 1, I guess, because like as we say, right, when it is arrays and all, it becomes 0 of n because the array requires n space. But it's just one integer, right? So integer will have only one space, right?
it will be
I
n
got
space.
confused.
You are absolutely right.
I'm
Okay,
thinking
let's
like, is
understand
it
this.
constant or
Let's see this. Let's this is the outermost loop, right? In I equals to 0, right? And then this is the innermost loop, which is in j equals to n, whatever the value is. Let's say 0. Let's say 0, right? This is the loop like this. Now this is our entire program, right? Let's understand. Let's understand how many times this line will be running. Let's understand from this perspective, right? How many times this line will be running if you run the program? Tell me. How many times this line will run? This is the initialization part. Fizula?
yeah,
One time,
one time?
right? Only one time, right? One time. Okay, fine. So let's say, and this will, let's say, now we will say this for loop will run how many times? Let's say from 0 to, let's say 100. It will run to 100, right? Let's say. So the value of I is less than 100 here. It will run till that part. Okay. And because of the how the for loops work, this space requirement is created only once for the entire for loop, right? How many iteration it may have, this thing will only run once, right? And this will create only one space in memory, right? Let's say this is our space. This is our space. So we created a variable of I equals to 0 there, let's say, right? It is a space. So this is done how many times for the entire loop of this for loop? Only once. We are okay on this part, right, everyone?
Yes.
Now let's move ahead. So we are now on this for loop, right? This for loop, right, is again doing int j equals to 0, right? So whenever this for loop will run, right, it will create a new space every time. I mean, so if you would look at this, right, int j equals 0, let's say j less than 100, right? Let's say 100 that 100, and it will be increasing the value. If you look at this for loop, right, the rule for the for loop is again same, right? For if this for loop, right, runs for this part, right? If this entire for loop runs, let's say for this case, right? So this for loop is running what? Let's say 0 to 100, right? It is running 0 to 100. So there also, like, how many times the value of j is getting assigned? Only once.
But it is a constant that we're completely continuously updating, right? It's only one place we're updating, keep on updating, right? We're not creating
No,
very new, right?
no. I think, see here, you are saying j equals to 0 here, right? You will create a memory space for this j equals 0, right? And this loop, right? Let's say the current value of I is 0 only, right? Let's understand from this perspective. The current value of I is 0. What will happen in this case? How many times this for loop will run? Tell me. This will run from 0 to 100. If a value of I is 0, as per the logic which I've written here, right? How many times this for loop will run? 0 to 100, right? For loop.
Yes.
So how many times you are initializing a space for j in this case? Only once, right? So for this, right, you create a space only one time. For I, you are creating a space for one time, right? Right. Now let's say the value of I became 1, right? This loop got completed. Now you move back to this. You have the value of I as 1 now, right? Again, what will happen? Again, what will happen, right? A new variable will be created. A new variable of j will be created, right? Right or wrong? You are
Yes.
initializing it, right? You are initializing j equals to 0 here. What will happen? Do you think it will go back and just reset this? It will reuse this value? No, right? It is a local variable, right? Local variable will end up as the scope completes, right? It has already taken the space already, right? And it was already consumed. It was already consumed. Now it is gone. With this new run, right? It will create a new local variable of j and initialize the value of what? 0 there, right? But okay, let me add Fizula. Yes, admit. Okay. Yeah, Fizula. I think you're there right now. Fizula, you're getting the point? No.
Yeah, I got the point. I got a little confused with space complexity and the time one because like we're not creating anything new, so why is it taking in and
No, it is we are creating new. We are creating new. Why you're saying we're not creating new?
we're not creating new data structures, right? So like the space complexity is based on the data structure. Suppose we create an array and all, it becomes 4n. We're not creating anything called the array and all, right? How will it become n? That was my doubt.
Okay.
For time
See,
complexity is n square, but for space, like we're not taking extra space. That's what.
you are taking an extra space. Try to understand, right? Let's say your for loop, right, wants your this value, right? Okay, let's do it. Let's run it, right? Let's say how many values you will create.
Because the thing is, it's override. That's what in my case, like in every iteration, it is overwritten, right? The variables according to the space.
Okay,
It
tell me.
becomes
Okay,
over.
okay. Tell me one thing, right? If I have a logic like this, right, where I have a for loop, right? Let's say the value of n is 100, right? The value of 100 there, right? In this program. Or did I copy that value, right? Where is this? Into z equals to 0. This one, right? We're talking about this. Uh, Not this. Sorry, this one only, right? So the value of n is 100 there, right? How many times this for loop will run? Tell me what's on this time.
Yeah, it will go to 100.
It will go to 0 to 100,
Yes.
right? It will go to 0 to 100. Okay, 0 to 100. Okay, fine. It will 0 to 100. And what are we doing here is we are saying, okay, so this is like number of times it will run, right? So this is saying number of times it will run. Number of times this for loop will run. Or I should say number of iterations, okay? Number of iterations within the for loop, within for loop, within for loop, right? In the combined 100 iterations of the for loop, tell me how many times are you initializing the value of I? How many spaces are you creating for I? Only one,
Yes.
right? Only one, right? Because it happens only in the first iteration of for loop, right? We are okay on this, Fizzler, right?
Yes.
I cannot hear you if you're saying yes.
Yeah, maybe my volume is low. Yes, I got.
So you understand this part, right? So we are creating I equals to 0, right? It will be int I equals to 0, right? So let's say this is the space block. So what will happen here is a variable int I. Let's not set to equal. Let's say a space for I is created allocated in this space, right? I, right? For this part. Now, as soon as you move down, right? Now tell me what is the value of. Let's make it simple, right? Let's just make it as 0 and let's make it 100 as of now, right? Or n, right? N. Now tell me how many times this for loop will the number of iteration which will happen for this for loop when the I is 0. When I is 0, right? How many times
Yeah.
this day will run? The number of iterations. Iteration will be
No,
100 only, right?
I 0 less than okay.
Let me do this thing. Right? Let me write it here. Let me write in a better
No,
way.
actually, I understood this one, but only one doubt was like when I was going through it, space means something we're creating an extra space, right? Like I told you, the data structures. Only if we use data structures, we are using space. But in our
Mhm.
case, we're not using any data structures over here, right? So it should be constant, I guess. That's what my doubt was. What we told about time is fine because it's running this many times. But space, we're not using anything extra, right? So if
When
we
you
create
when
only data structures, then space comes into picture.
Okay, you are saying when I create only data, when you say data structure, you mean arrays, links,
Yes,
sets.
list, yeah,
Okay.
stats,
You do
heap,
not you do not mean by the variables. You think like variables will not take space?
yeah, that is confusing me. Is it because variables also take space, or is it just the data structures that is taking
Definitely,
space?
definitely, right? Variables also take space, right? And if you just start creating space without any reason, right, your memory will get exhausted, right? Your variables take space, right? If you create a variable of double or long, right, how many space it takes? 64 bits, right? If you create an array of one size of which is of long, right, how many space will that array take? It will
Yeah,
take some
understood.
space, right?
Yeah, yeah, got it. Okay.
Right? It will take some space. So the point here is when you are running this nested for loop, right? When you're running this nested for loop, try to understand in once this for loop is running, right? Once this for loop is running, right? Let me know. Just try to write it here. This is the outer for loop. Int I equals to 0. My pen, I will fix my pen today. This is not working correctly. And I less than 100, let's say, right? And you have a for loop here, and you will say int j equals to 0, int j equals to 0, 0, and j less than that, right? You're doing this. Now, let's try to understand what we are saying in all this. Right? Let me write it here. So we'll first space a space box. Okay, this is my space box, right? Where I will just create the space for the variables which I need. And I will also tell here like how many times the for loop will run. So this is like say A for loop, right? This is the A for loop. This is the B for loop, right? Let's start doing this. So if I am over here, right, my program control is here for running this program, for running this line of code, right? In this for loop, I seeing that I need a variable I, right? So I need a space for it. So I created the space for it, right? I created a space. Now let's see how many times the A for loop will run. The A for loop, right, will run from 0 to 100, let's say, right? 100 times. Now tell me with when you are running it 100 times, this for loop, right? This for loop, the number of iterations which are running it is hundreds, right? But how many times the for loop is working? For loop is working only one time, right? It has 100 iterations. It's a different case. But how many times the for loop is running? For loop, this line of code, right, will run. I mean, for loop will run only once, right? I mean, the number of iterations are 100 there. And as part of the 100 iterations, how many times you need to initialize the variable of I? Only once. We understand this part, right? Because initialization thing, right, when the for loop happens in the first iteration. So as soon as the first iteration goes, right, you will have this value of you will have a space of I created in the space memory, right, like this. And in the subsequent things, right, it will not require to create a new variable in the space, right? We agree on this, right? For the A loop, right? For this the outer loop, right? Now, but what is happening in the case of the inner loop? Inner loop, right? When the value of I is 1, right? The outer loop, the inner loop will run, right? And it will run how many times? Let's say 100 times, right? And the value of you're creating a variable called j there, right? Right. So as soon as the first iteration runs, right, you will create a space. You will create a variable for the space for the variable j, and you have it here, right? And mind you, right, it's a local variable, right? It's a local variable, but it still needs a space, right? It will still need a space, so it is added here, right? As soon as this for loop, right, completes all the 100 runs, right, all the 100 runs, okay, during this 100 run, will you be creating a new variable of j again? No, right? Because creation of the variable of j happens in the first iteration only, right? Let's say, and the subsequent iterations, it will consume the j which already had a space in memory. The value will be updated in the memory in the space every time, right? The overriding part, which you are saying, right? It is happening during these iterations, right? It is overwriting the value of j. Earlier it was 0, it will be set to 1, it will be 2, it will be 100, right? It will be doing that like that. Now let's say this loop complete, right? And this is a local variable here, right, within it. So as soon as your local variable is done, right, it will be gone, right? It will be gone. But it has already taken one space already, right? So one space has already been taken by j in the first in first time the B loop was running. Now the value of I becomes 2. What will happen? The for loop, the B loop will run again, right? How many times? With 100 iterations. And here, when you're running, right, you're running these iterations from the starting, right? From the first iteration. Again, it will do what? It needs a variable of j. It will go here and create a variable j again, right? And then it will set the value of j from 0 to 100, right? As per the iterations. Then again it will, and once the loop completes, it is gone. So how many spaces were required for j? 2. Already 2 with the 2 iterations. Now the iteration changed to third. What will happen again? Again you need a variable for j, right? So again a variable of j would be created, and you will initialize it from 0 to 100, right? And you will keep on doing it as many times the a loop is running. So a was running 100, so you need j variable to be created 100 times. It is getting created, it is getting destroyed at as the for loop is getting completed, right? So for this j, how many times it is getting created? 100 times. How many times is I is getting? One time, right? Right?
Yeah,
And why I said
both
100
are
times?
constant values, right? 100 is constant. Like,
Okay, 100 is constant. Let's say I have, let's say this is 100. Why this is 100? Because I have set this 100, right? Let's say it was n. It was n, right? And I have an input which is saying method 1, and I'm taking the input of int m n here, right? Now tell me, what could be the value of n? It could be anything, right? It could be 1, it could be 10, it could be 100, it could be 1 million, right? You're understanding the point, right?
this is understood. Got it.
So if it is 100, if it is okay, if it is n here, right? It will be n here, right? It will be n here, right? In this case. So how many times your for loop will run? If it is 1 million, it will run this for loop 1 million time, right?
Yes.
So your j variable will be created how many times? 1 million time, right? So you will term it as what? It needs n space, right? Depending on your inputs here, right?
Okay. Okay.
So in total, how many space you need? N for this for loop and 1 space for the I. So you will generalize it and you will say n, right? So the space complexity for this becomes what? Na, right? And see, that is the problem, right? That is one of the problem which we should be, I mean, we should look at, right? When we are creating variables inside a logic, right? We need to understand how many times are we creating it. That's why people when they are reviewing your code, right, they tell you why are you creating a new variable, right? And they will have a very strict check when they are when you are iterating it through multiple times, right? Because every time you create, let's say I do something like this. I create one more variable inside this. Let's say int z equals to 0, right? And what I'm doing is I just want to add the values. Someone will say that you are doing a rubbish here, right? Why are you creating a variable like this? Again, it can depend on the context also. Maybe in that context this may make sense, right? But someone will say, someone can easily come here and say, why are you doing this here? Because for every nested for loop, this will be created every time, right? Is it really required? Because as soon as you do this, it will need a space here, right? And let's say someone runs this 1 million times, you will create 1 million spaces there, right? Okay. See, this is my understanding. What I feel like this should be n space. If you think it is not n, let me know, right? I am open for the discussion. Maybe I could be wrong, but as per my understanding, this should be n. And I hope the explanation which I am giving is making
Yeah,
sense.
I understand. Maybe I got confused because, like, somewhere I learned, like, because for the integers, because they have constant memory space, it becomes O of 1. It was somewhere I read that, so maybe that's right in my mind.
See, I also remember that part, what you said, right? So you are also right in when you say this, right? But it has to be seen like it does take constant memory space. But the point here is that how many times are you creating that space?
Yeah, yeah,
That is the whole idea. It is constant value, which is okay. See, even if you create array, how much space that array takes? Let's say I create an array of int uh, array one, right? And I say new int one. Let's say I'm creating an array of one size. will you just say that how many space will you consider for this? You will consider n here. No, right? What is the space you're taking here? Only one space, right? Which is for n, for an int only. So it is as good as you're writing this int a equals to 65. If you do this, or you do something like this, right? If you do array 1 equals to 65. So you're putting 65 in a box, right? Which is an array. But here you're taking like this. How many space do you need? 32 bits. How many space? 32 bits. There is one more additional thing that you would require one object to be created for this, right? A new object would be created in the heap memory also, which is fine. You will create an object here. But you need space, right? In this part also. Again, this is as per my understanding. I will recheck whether this is, I mean, whether we only consider the space taken in the heap memory. If that is the case, then your point is valid because we are not creating an object. But I don't think that is the point. The point is about the holistic memory which you are taking. This is also a space, right? You cannot say like this is not a space. This is a space. It is taking 32 bits of your space, and you are doing it, and you are creating that space every time, right? You are not reusing it. You are creating that space every time. You're destroying it and reusing it. But I will recheck. I think let's take a recheck on that part. But I feel what I said is okay. But let me recheck also. But again, if they would have told me this, I could have told you. So as per you, what do you think? What is the space complexity one?
O of 1.
Okay, you say O of one. Okay, I'll check this point. Okay, I'll check this point. As per me, it should be O of n, at least in our case. But let me recheck. Okay, but this is about space complexity and time complexity, and we will start moving ahead now from tomorrow's class. And but every program will solve, right? We'll try to find the complexity in both the parameters, time complexity and space complexity. Okay. Okay, I think we are good for today for the DSA part, right? And I will recheck this and update you. Okay, maybe I could be wrong. I'm not sure. Let's check, right? And I will confirm back. Okay, thank you so much, right? Let's meet in the evening. Bye bye. Take care. Have a nice day.
Yeah, thanks. Bye.
Yeah, thank you.